So, Mr. Mikey, good to have you back.
Good to be back, brother.
Bryan's been concentrating on a whole lot of things. One of the things that Bryan's been concentrating on, what is on Mike's mind? And as you can see,
That's a scary thought.
There's a lot on Mike's mind.
I'm not sure I have a mind.
But one of the things that he's picked up on the various tech support calls is refrigeration circuit questions. And a lot of it has been pointed to the metering devices, cap tubes, flow raters, expansion valves. And I know you're going to hit on this subject, hence the whiteboard.
Mm-hmm.
But the EER rating or SEER ratings of the machines are going crazy.
Yeah.
With today's technologies and being able to put, I never thought I'd see the day where you had EXVs in a residential unit and EXV boards and all that stuff. But all that base, what that all is about is getting the SEER ratings up.
Yep.
and consuming less energy, less global warming, less carbon footprint.
Did you ever think you'd ever see variable speed compressors in residential?
I did not, nor variable speed ECM motors.
Mm-hmm. Exactly.
But
So-
then again, I'm not old.
At least not compared to me.
But that being said, a lot of the common things that Mike has gotten questions on is guys that are walking up to these high SEER units and they're mix matched. So I know you're gonna, like I say, I know you're gonna
Yep.
explain this further, but you guys got questions on this stuff. That's what we're here for. You can always text us. You can hit us up on our forum. The
Yep.
forum has a place in there where you can ask questions. You can look up previous questions. If you've got a question on a specific machine, you've got a topic that you want to look up, you can do a search for topics, or you can just jump on the forum and ask a new question.
Or you can turn around and actually answer questions. So if you've got experience on something
Yep.
that you see a question on, jump in and answer it. I mean, there's a lot of guys out there that have got a lot of experience, but we would really love to take advantage of them sharing and helping to share some of those experiences and stuff.
That's
So
really what we're here for, is to help everybody.
the
So
one disclaimer, we are not going to tolerate any picking on the youngsters or criticizing or putting down. That's not what Blue On is about. That's not what this forum is about. This is about helping each other. It's about being positive. I mean, I get young guys call me and they said, you know, I don't know if I should be calling. I've only been in the trade for a week. My response is, welcome to the trade, and I hope you can have as much fun as I've had over the last 48 years. So it's about helping, guys. Let's keep it positive. You know, there's even a place on there for memes and some funny stuff, and you know, we're all good with all that. But you know, in all seriousness, this is about helping the next generation to be better, to improve their skill sets.
yeah,
Because people took the time to help me. I had 3 or 4 guys that were the big, you know, key in my life coming up in the trade, and I want to return that to the young guys. And I know you feel the same way.
yeah. It's nice to have somebody under your wing or got your back. Blue On's got your back is our tag. And Mike's going to show you when we get into this. And of course, we want questions from you guys, but again, on the high SEER equipment, if you've got a 16 or above SEER machine and you walk in and look at the evaporator and it's got a cap tube or it's got a fixed orifice, AccuFlow or a piston, guys, that's not a 16 SEER machine.
That is not.
So that's when I say mix match, that's what I'm talking about. Putting a 16 SEER condensing unit on a 10 SEER evaporator does not equate to a 14 SEER machine. It doesn't work.
Okay, so my math hasn't been my strong point, so anyway, just kidding. What prompted a lot of this is I got a phone call from a young technician, and I've gotten a few of them, and he says, I've got this 18 SEER machine, and I decided to put a piston in it instead of a TXV. The problem is they did cap tubes, they did pistons, they did all that kind of stuff. And what was the biggest reason they did it? Because they were cheap. And so as long as they were cheap and there was no driving force to get the energy efficiency up, this industry does not move unless prompted to do so.
Right.
So, you know, what they've done, you got a couple things you can do to make equipment more efficient. You can put more coils in it, that costs a lot of money, or you can go to an active metering device. And I'm going to use the term active and passive metering devices. Your cap tubes, your pistons, your flow raters, Accutrolls, a few other things, that's a passive device. There's no controlling element to that. Whereas a thermostatic expansion valve is reacting to things, it's an active device. So
cap tubes, AccuFlow, pistons, passive, meaning it's a fixed size diameter hole that does not adjust to what's going on with the system. It's not looking at return air. It's not looking at the suction pressure.
right.
It doesn't even care about the liquid temperature, pressure, none of that has
Well,
an
it
effect
does.
on a piston.
It does.
Cap tube,
On piston too.
piston?
Yeah. And here's another
Do
thing.
explain, Mike.
I will explain. But here's the other thing. What's the difference between a piston and an orifice? Pistons are used in heat pumps. Orifices are used in straight cooling.
See?
All
That's
right.
why we keep him around.
So let me start off with this. And this right here is just about as basic as we get.
I got this and I got the belt.
There we go. So I'll watch the bad words. So we come out of the compressor, we go through the condenser. In the condenser, as I was talking to one of our new people, it's really kind of cool. Air conditioning guys aren't that sharp, so they make the words real simple for us. So the condenser is where the refrigerant condenses. All right?
does.
It does.
It's amazing that items do what they're named, okay? Condensers condense, evaporators evaporate, refrigerators refrigerate,
And compressors do
toast.
what?
They pump.
They compress. So anyway, we leave the compressor here and we go into the condenser. Now, in most cases, you're going to have a fan blowing air across there, and that's going to help condense the refrigerant. And we're going to come up to the cap tube, and we're going to have a decent column of liquid there that is not saturated. It's subcooled. And all the cap tube is a device to control the flow of refrigerant going into the evaporator. All right. As it comes out of the cap tube, we're going to have our adiabatic expansion take place where we get that flashing off, and we're going to go in with a majority liquid. And as we go through the evaporator, we are going to absorb all that heat. Well, the things that changes the flow through a cap tube is if this gets really cold, the pressure is going to drop. If it gets really, really hot out here and the pressure goes up, you're going to have a higher differential pressure and it's going to cause more flow. Cap tube systems are critically charged. So we've only got so much refrigerant in this system, and when we get maxed out, we don't got no more. It's all pretty much done. Cap tubes, pistons, orifices, Accutrolls, flow raters, and theoretically a manual TXV,
Yeah.
a manual expansion valve, are all your passive devices. All right. So not a lot going on. We could end up with a coil that's starving for refrigerant under the right conditions, or we could end up with a system that's overfeeding under some conditions. So we're not going to be consistent on our energy usage. Our coil is going to be operating differently all throughout different conditions and everything. So what they did is they started off with these automatic expansion valves, which were kind of a disaster. But go ahead.
Before we get into that, you hit a key point. As it's going through, you really have no control over that. And so that's why we use the target superheat
Yes.
calculator, because it will take the outdoor conditions, the indoor conditions at that time to tell you what your superheat at the compressor should be on the suction line.
And I'm glad you brought that up, because many years ago, when I would talk to people, because I came from a world where cap tubes were non-existent. You don't use them on 2,000-ton systems. They're not there. So anyway, so everything with me was expansion valves. And so when I come back, I said, so what target superheat do you go for? And everybody says, well, 12. And I'm like, oh, wow, okay. And I started looking at it, and I'm like, no, that ain't right. Your superheats can go anywhere between about 5 and 50 degrees of superheat
Yep.
on a small system.
Depending upon those 2 points.
Now, most manufacturers were really, really nice. They put this really nice sticker on the side of the unit. Well, that was great. There was only one little problem. There's this thing called rain and sun and smog and air pollution and everything else, and the guy throwing the panel across the ground. So you get out there and there's nothing there.
Right.
And basically all you're doing is you're taking a return air wet bulb and an outdoor dry bulb, and you're bringing the two things across, and it gives you a target superheat. Well, that's great if you've got all the data still there. The problem is most of the time it's gone. So Blue-On, gotta love those guys, gotta love those engineers and the people that do the app and everything else.
Gotta love tech support.
Gotta love them. They turn around and they created a target superheat. And so what you do is you take the return air wet bulb and the outdoor air dry bulb, and you plug that in, and it'll give you a target superheat. Now, we've run into some people that don't have ways of measuring return air wet bulb. And there's one, go ahead. Yeah, you. Yeah, you're in trouble if you don't have shoelaces.
That's right. But look, I got shoelaces. You don't have shoelaces. I got shoelaces.
I don't need shoelaces. You're lucky I put sandals on. So anyway, so what Jed, mechanical engineer, did, really, really cool. He's got outdoor dry bulb. He's got return air, and it's supposed to be dry bulb. It says wet bulb, but it's return air dry bulb. And then kind of pick. So if you're down south, grab 60% relative humidity. If you're somewhere around Texas or somewhere like that, go ahead and grab like maybe 40. If you're in Arizona, you're screwed. You got no humidity. So
but the nice part about the app and our target superheat calculator is you can do it both ways.
You can do it both ways.
They have the return air wet bulb and the outside air dry bulb. And there's also the guesstimate of here's my indoor dry bulb, my outdoor dry bulb, and my relative humidity is about, if you got a phone, you can look it up and it'll tell you where you're at and what the relative humidity is at that time where you're standing. But
the one with the return air wet bulb is going to be more accurate, but the other one gives you a way to get in the ballpark, because if you got nothing else, at least it's going to get you there, and you can do.
And two, the other thing that they built into it is when you open up that calculator, it has your safety built into it. You're going to see numbers for your target already. So if you don't fill anything out, it's going to have a 5 as the minimum superheat. We don't want you guys to blow up compressors. So
yes, because we're not compressor manufacturers, so we don't make anything when they blow up.
But so it's just a safety built in. It's a safety built in that even if you do put your numbers in and your numbers are off the benchmark, Mike was talking about the crossing left to right, your X's and Y's. If you're off that chart, then you will look and you'll see that 5 didn't change, and that's because you're off the chart. If you put your numbers in and it still shows what you saw when you opened up the app, it's only just the safety factor.
Yep. So this gives you a way to do things, but like you can see, we have basically a weight-in charge. It's a critical charge. So when we have no more refrigerant in there, that's all the system can do.
Yep.
All right. So what happens, and here's the difference, is if you go to an active metering device, all right, we still have the compressor, we still have the condenser. A lot of times I'll put a sight glass, okay? That sight glass tells us if we have a good column of liquid, a nice subcooled liquid going to that valve, because we don't want to put a saturated refrigerant through there where we're only 75% liquid and 25% vapor, because now we're not going to get the cooling. So this will tell us that we've got a full column of liquid. An even better way to do it would be to measure your subcooling there and figure out where your subcooling is at. Typically, if you don't have a receiver, anything around 10 degrees of subtooling is great, all right? Now, this thermostatic expansion valve has got a sensing element down here reading the suction coming off the evaporator. And what it does is it wants to give, typically you set these up for about 12 degrees. So what happens is, if I'm not opening this valve far enough, this valve is going to see that. It's going to exert a pressure on the TXV, and it's going to open the valve. So it's always adjusting based upon conditions. All right. So if my air temperature changes, if my air volume changes, I'm going to get changes taking place here in the evaporator, and the valve is going to respond to that. All right. I mean, theoretically, in a perfect world, we would boil off all the refrigerant right before it went into the compressor so that we were getting the most work out of our coil and everything else. The problem with that is because valves are kind of sloppy and they can only turn down so far. If we go too far, then under the right conditions, we could cause floodback and do damage to the compressor. So I think you can see here, if I'm controlling my refrigerant in this coil, I don't care what the outdoor temperatures are. I don't care about any of that other kind of stuff. This is simply looking at what's going on in the coil, and it's responding accordingly. So by using this, we're a lot more efficient, and so we're not turning around running the system and only feeding part of the coil. So I think you can see why having an active device that's responding to the system is going to be more efficient than a cap tube or piston or things like that.
Exactly.
So just kind of wanted to hit this because, sometimes people just don't think it through. They work on it all the time and they never really think what's going on and everything.
Well, it's a good piece. It's not only a good piece for the new guys coming in, but it's,
Yep.
for this to work, it needs to see this quite frequently.
Yep.
So, but you mentioned a good term,
Which one?
floodback.
Floodback.
Floodback, as everybody knows in the industry, compressors do not pump liquid.
At least not very
pump
long.
Vapor. They're designed to pump vapor.
Yes, they are.
If they start pumping liquid, they have a tendency to break.
That's because you can't compress a liquid, but now even if you just get droplets of liquid coming back, it can wash the lubrication out of your bearings.
That's oil.
Yep. Because that nice droplet of refrigerant just turned around and hit that warm bearing, it flashed off, and refrigerant's a great solvent.
It's a great degreaser.
And it turns around, and now you don't have oil lubricating that bearing surface, and you tear up the bearings.
So floodback, the definition of floodback is liquid refrigerant entering the compressor, which it should not do. Good one, Mikey.
Unless you're using liquid cooling. So I just kind of wanted to cover this here. Now, I have had people in Canada where they have trouble getting some of the parts in a timely manner. And so we had one young man that went over to a piston because it was a 3-week lead time on getting the expansion valve.
Oh, well, we're mechanics. I mean,
Yeah.
we are going to do mechanics, technicians, sorry, interchangeable there, old guy. But we do what we got to do
Right.
to get the client up and running.
And he told the client, this is not going to be as efficient as it was, but as soon as that part comes in, I'm going to come change it
Yep.
and everything else. Here's another thing too. If you slightly overcharge something with an active metering device, it's a lot more forgiving because you'll just stack the refrigerant in the liquid line.
Stack the refrigerant.
There we go.
So stacking the condenser means at 10 degrees of subcool, you had one pipe full of liquid. If we went to 12 degrees, we had 2 pipes of liquid, which means we're stacking the condenser. When you are looking at a condenser coil, the discharge pipe of the compressor goes into the top of that coil. As it cools, down at the bottom is the liquid. So when we say stacking, it's literally stacking tubes. If that makes it easier for you to understand that.
Now, I want to hit the term saturation because
Yes.
I think it's very, very important. Saturation, by definition, is that in your refrigerant, you have at least one molecule of liquid or one molecule of vapor. Because once you become 100% liquid, any heat we remove out of that liquid is now subcooling that liquid refrigerant. On superheat, once we go 100% vapor, all the heat that is continually added on the way back to the compressor is superheat. So it's heating the vapor after the change of state has taken place. And what's really cool is you can do a lot of fun things with saturation.
Again.
Because you can look at a PT chart and know what that saturated refrigerant pressure temperature relationship is.
Yeah.
Here's a flooding question. How do you know if it's flooding back?
Compressor will scream at you for one.
Well, yeah, first of all, you're going to hear the compressor is going to get angry. You need a temperature clamp and a pressure gauge. Put your temperature clamp on the suction line. You need to be 6 to 8 inches away from the compressor.
Why?
So you don't pick up heat from the compressor itself.
Go.
Good question.
No, good answer.
So you put your temperature clamp on, you have your pressure gauge on. You take the pressure that you read on the gauge, convert that to the saturation temperature that you read on the chart, take the physical temperature from the clamp on the pipe, subtract the converted temperature from the actual temperature, and that will tell you what your superheat is. If your superheat is 0 or a negative number, you're flooding back.
I see, Bryan,
In some cases, it's 1.
God, he did a lot of work there. I'm going to give you guys a little secret. I'm going to let you in on a little secret. In the Blue On app, there's a subcooling and superheat calculator that now has all the standard refrigerants today.
Exactly correct.
So make your life easy and go use the Blue On app and use the subcool and superheat calculator.
By putting your clamp on the pipe.
Yep.
And putting in if you put in the refrigerant and the pressure and the actual temperature, it will calculate it for you. You don't have to do math. Because remember, a long time ago, in one of these buckle ups, I told you when I got in the trade, they told me there would be no math, and we're getting a hell of a lot closer, brother.
We are.
Because they lied. This trade's
We
got
are.
a lot of math in it.
Good answer.
Thanks, Mike.
Yeah.
Kudos from the Mikey.
How do you know the amount refrigerant in a system if it has a liquid line receiver?
There are a couple ways you can do that.
Yeah.
But it's kind of like, who
There's
cares?
a boatload. Again, that gets into a whole lot of math. You got to know the size of the pipe, whether it's vapor or liquid, and you can do all the calculations off a linear feet. You can also pump it all into that receiver, valve it off, and take a liquid level measurement, find out what the volume is. There's a lot of ways you can do that. You can get a lot of recovery cylinders and remove all of the refrigerant and actually weigh it.
You can let
But
the,
yeah,
you can let the system start when it's hot, so the valves drive wide open. And if you don't have enough refrigerant to feed the valves, you're not going to have anything in the way of subcooling. So,
And the receiver will be empty.
Yep.
But to calculate how much total refrigerant you have in a system, you're really going to have to do math. There's more work to it. You can't just walk up and do it.
or we just call Jed.
We call Jed. The other way of doing it, it's still a wag, it's still a wild ass guess, is somebody designed that system that's got a receiver in it. That receiver is designed to hold 100% of the refrigerant at 80% of the cylinder. If you know what the size of the cylinder capacity is 100%, take 20% away from that, and that should be your refrigerant capacity in the system.
Good answer.
That was a lot to
There was
say.
a lot there.
If you had 100-pound cylinder and did that 20% math, that means that system would have 80 pounds of refrigerant in it.
I missed the first part. Can you back and repeat it?
Yeah, no.
Is superheat and subcooling the same in the winter on a heat pump?
The big difference is that in the winter, you're going to be working off of the outdoor metering device because you're absorbing the heat in the outdoor coil and you're having free flow through the indoor coil, so you're bypassing the metering device on the indoor coil.
You're bypassing the metering device, yes, because your liquid line is still your liquid line. but your suction line is no longer your suction line, it's the discharge line. If you wanted to calculate superheat and subcool, you have to know the head pressure and the liquid temperature, and you also have to be on the suction side of the reversing valve, as well as having your gauge on the true suction line on the unit.
Cool.
So you can still do the math. I would not look at a chart and go, these are my cooling, manufacturer recommends 12 degrees of superheat and 10 degrees of subcool when running and cooling. Those are not your superheat and subcool numbers for heating, no. But yes, basically you read it the same.
Mm-hmm.
How do you know the pressure is good in heat mode on a heat pump?
Charge it in the cooling mode.
I've heard a lot of rule of thumb to know whether or not your charge is correct on a heat pump on 410A, and I don't know whether it works on all the other refrigerants. I do know that on 410A, the rule of thumb is 30 degrees above ambient discharge line. If the discharge line is 30 degrees above what it is outside, then your charge is pretty daggone close. Daggone close. While we're waiting for another question, these guys are gonna love this. I remember the first train IntelliPack that I ever worked on. My journeyman, we climb up on this roof. He opens up the double door panel on the end, because now they put them on the side. Back then they were on the end. He opens up the double door panel, and all I'm looking at is 2 walls of Essex relays and black wire. And he looks at me and goes, I'm gonna go get us a couple of burgers. When I get back, you tell me what's wrong with it. I say that because it's stuck in my mind forever. And the second part of it that's stuck in my mind forever is always start troubleshooting at the same point. When he got back, he's going, I got the burgers, what's wrong with it? And I'm still reading the voltage on all these stupid relays. And he goes, what's the transformer doing? Walk over, read, no voltage coming out of the transformer. He pulls a fuse, unscrews it, screws it back in. The machine starts, we close the door, we go down and have a burger. The point of the moral of the story, doesn't matter what the size of the machine is, it's got the 4 basic components no matter what, and always start your troubleshooting in the same spot. Make sure you got main voltage, make sure you've got control voltage, make sure your fuses aren't blown, and you just walk through it from there. It doesn't matter whether it's got 1 compressor or 15 compressors. It doesn't matter whether that compressor is a 1 ton or a 5,000 ton. It's got 4 basic components.
Let me throw one other thing in there. If you go up on a roof and you've got a cooling problem, you're not going to look at any of the heating stuff. So you can already automatically get rid of that stuff. You know that's not where you've got to look. So you start looking on the things that are for your compressor, or do I have fan? If I've got fan, chances are I've got my transformer and everything.
Good chance that you've got control voltage if the indoor blower is running.
Yep, so now I can turn around and it's like, okay, the low pressure switch might be keeping the compressor out, the high pressure switch, a thermal overload. But look at what the system's doing, because you can eliminate some of those steps.
Yeah.
But if you don't know what's going on, you got to start with your basics, because I don't care how big it gets, everything is based on your basics. You just adding more components, more controls, and it just grows.
Yeah, it's like going to a car dealership. You can get a car with manual windows. It's still got windows.
Mm-hmm.
But you can get an upgrade and you can get that electric window.
Bryan, I don't think a lot of these guys have ever seen cars with crank windows.
No, these guys have never seen cars without air conditioning.
How do you know thermal overload is open on a compressor?
Compressor won't run.
That's good. That's a first indicator. Second indicator is you can fry an egg on it. Third indicator is actually take your own meter out and ohm the windings. If the compressor is cold to the touch or cool, meaning that you can put your hand on it for more than 5 seconds, that's cool to the touch. Now you ohm the windings. If the windings are still OL, then chances are you need to change the compressor. If you touch it and you can't, I mean, you're touching that compressor and you can't touch that compressor for more than 3 seconds, that compressor is extremely hot. You can ohm out the winding and it's probably open on, the overload's probably open.
Yep.
They make tools now that you can put on a garden hose that magnets to the top of the compressor, and instead of flooding the person's backyard, it just trickles some water out on those compressors and it helps cool them down.
Got a few more questions.
Okay.
This is a cool comment. Just joined Blue On today. You are all amazing. Can't wait to use it in the field.
Welcome on board.
Welcome aboard, brother.
Welcome to the
Or
PUD.
sister. She didn't say what your name was.
We
so.
hit 65,000 people on our app today, which is wild. So thank you guys for all the support you always give us. We really appreciate it. And what we do is completely free. So we're just here to help you guys out. So
Just
tell
remember
your
it.
friends. Tell your friends, download the app.
If there's some topics that you guys really want to get into, let us know. Because Bryan and I sit there, Jess sends us an email and says, what's our topic going to be? And we try to grab something that we, off the tech support calls for the week and everything else to try to come up with something that's going to be beneficial to you guys.
At Blue On Community, at
Blue On Bryan.
See, they don't
We're
trust
here.
me with that kind of communication.
Well, it's got something to do with a tookus, and I'm not exactly sure what they
Okay.
meant by that.
All right, we'll have to explain that at a later date.
Before we go, reminding everyone that the Blue On forum is now live in the Blue On app. So this app is still completely free, just another tab at the bottom. So go into the App Store, hit update if you haven't already, update your Blue On app, and you'll have access to this first amazing HVAC forum where you can ask questions, answer other people's questions. There's no censorship, no BS, nothing like that at all. So it's super easy to find information, super fast, easily tagged, posts, everything like that. So we've been working on this for years now. So we're super excited. It's live. Again, it's totally free.
And it doesn't stop. We continue to add.
Yep. Every day there's new posts in there, just helping techs out. It's really, really cool. So be sure to check it out. Tell your friends. Again, totally free.
Manuals and equipment, we're almost at 50,000 pieces of equipment in there. Almost.
And reminder, if you are working on a piece of equipment that you can't find in the app, just call up tech support and they will get what you need easily, even if it's not in the app. So,
Yep.
little reminder.
Pick me. Love you guys. Thank you very
Peace,
much.
y'all.
Peace out.
Y'all have a
See you in 2
great
Thursdays.
week.
Woo.
Peace.